Hey everyone, and welcome. Today, we're going to tear down a course that, let's be honest, might make some of you a little nervous. STIQ 1013, Mathematics for Information Technology. I know, you're probably thinking, math? Seriously? For IT? I thought I left that stuff behind in high school. But stick with me, because you're about to find out why this course is the secret weapon for your entire tech career. Look, I totally get it. You signed up to build awesome software, to figure out complex networks, not to get lost in a sea of equations. And you know what? That's a totally fair question. But the answer? Well, the answer is way, way cooler than you might think. Here's the big secret. Math is literally everywhere in tech. Every time you see mind-blowing special effects in a movie, or when your favorite streaming service recommends a new show that you actually love, or when a company uses data to make a billion-dollar decision. What you're really seeing is math doing the heavy lifting. It's the hidden engine, the invisible framework that makes all the cool stuff possible. So here's our game plan. First, we're going to talk about why math is basically an IT superpower. Then, we'll crack open the course itself and look at its two big pillars, linear algebra and calculus. And to wrap it all up, we'll see exactly what kind of powerful new tools you'll walk away with. Sound good? Let's do this.
Okay, first things first. Before we get into all the details, we have to tackle the big question. Why? Why on earth is math so fundamental to everything you want to do in information technology?
And to get our answer, we're going straight to the source. This right here is the official syllabus for the course, and it's going to be our roadmap. It's all laid out in black and white exactly why this kind of math is an absolute must-have for anyone who's serious about a future in tech. And boom, right there in the course synopsis, we get our first major clue. The whole course is built on these two powerful domains, linear algebra and calculus. These aren't just some random topics they pulled out of a hat. They are the bedrock of so much of modern technology. All right, so we've got the why covered. Now let's dig into the what. What are you actually going to be learning inside this course? How's it put together? And what are these two big ideas all about? You can really think of this course in two halves. On one side, you've got linear algebra. This is the language of data, space, and how things are organized. It's the magic behind 3D graphics and huge databases. Then on the other side, you've got calculus. This is the language of change, of motion, and of making things better. It's the secret sauce behind things like machine learning and realistic video game physics. Okay, let's jump into that first pillar, linear algebra. At its core, this is all about taking huge, messy piles of information and giving them a clear structure so that we can actually work with them. And the absolute hero of linear algebra is this thing called a matrix. Now, it just looks like a simple grid of numbers, right? But don't let that fool you. A matrix is an insanely powerful tool. It can represent anything from the pixels in a photo on your phone to the complex web of friendships on a social network. So in this part of the course, you're going to get your hands dirty with the essentials. You'll learn how to work with matrices, how to use them to solve really complex problems, and you'll get into vectors, which are basically the building blocks for any kind of 3D modeling or game physics. All right, let's flip over to our second pillar, calculus. So if linear algebra is all about structure, calculus is all about change. It's about movement and about finding the absolute best, most optimized way to do something. A huge idea here is something called differentiation. It's basically a way to find the exact, instantaneous rate of change, like finding the precise speed of a car at one specific moment. And in the tech world, that's a total game changer. It's how a machine learning model actually learns from its mistakes and gets smarter and smarter over time. So in this section, you'll be digging into functions that can model how things grow in the real world. You'll master differentiation to make those models as efficient as possible, and you'll learn about integration, which is crucial for things like calculating probabilities and analyzing massive data sets. So, you've learned about matrices, you've learned about derivatives, but what's the real point? What's the big payoff for all this work? Well, let's talk about the incredible new toolkit you're about to add to your arsenal. The mission of this course is super clear. This isn't about learning theory for the sake of theory. It's all about understanding how these math concepts are actually applied everywhere, from the apps you use every day to the most cutting-edge technology on the planet. Now this slide, this is where it all comes together. It takes those official academic-sounding learning outcomes and translates them into actual real-world superpowers. You won't just be describing techniques. You'll be speaking the language that powers advanced tech. You won't just solve problems. You'll be ready to take on the biggest, most complex challenges in the entire industry. And you know, it's not even just about the math itself. This course is specifically designed to build the exact skills that every single tech employer is looking for: critical thinking, problem solving, teamwork, and, this is a big one, the ability to keep learning for your entire life. This isn't just a math class, it's a launch pad for your whole career.
So by the end of this, you're going to have a toolkit that goes so far beyond just coding. You'll have the power to truly understand, to build, and to optimize the technologies that will define our future. The only real question left is, what problem are you going to solve first?